The climate is changing. Oceans are warming. Extreme weather is more common. Threatened species are under strain. Whether we accept it or not, it's happening. What we might do about it is up to us. We're on borrowed time.
I'm Andrew Murphy of the Mill Valley Public Library, recording on behalf of the Borrowed Time series. Today I'm interviewing Brian Fisher. Brian is the curator of entomology at the California Academy of Sciences and has spent the last 3 decades documenting the island of Madagascar's biodiversity. Along the way, he's discovered 1,000 new ant species, including the jumping and Dracula ants. He's known to some as the Ant-Man. He's also the founder of AntWeb, which is the largest online database of all things ants, and is the author of a field guide called Ants of North America. So Brian, welcome.
Thank you. Thank you, Andrew. Glad to be here.
Well, let's talk about the birds and the bees. Why are they all dying?
The birds and bees, why are they dying? Well, that's a big question. You may have heard that insects in particular might be dying. It's the apocalypse of the insects. And I look at insects as the canary in the coal mine. They have a high turnover of their lifespan. So they're changing faster than we are. They're like the pulse of the planet. And if they're disappearing, that's telling us something. What's even scarier, they've been disappearing for the last 30 years, and we may not have even known it. As an entomologist, I doubted that insects could be disappearing. I collect a lot of insects. I get buckets of insects. Don't tell me they're disappearing. But the more data we get, it's getting clearer and clearer that insect populations, especially around urban areas, are declining. And that's a surprise. Now, it's clear that lions are declining, tigers are declining, but the insects, the glue of our ecosystems is also declining. And, it's important, especially around this season of togetherness, to think about what fabric holds us together. And it's, in a sense, the insects. And they could be declining. And what that means for humans, for our ecosystem, which we're a part of, we don't know.
And is there a correlation between the massive die-off of the birds that's been reported this year as well and the insects?
Well, I think, birds and large mammals have been declining for a long time. There's like only 3,000 tigers left. That's nothing. That's nothing compared to their natural populations before. I think sometimes we forget the abundance of nature. How many whales there were, how many sea lions, how many penguins. But likewise, there were always that many insects. Now, sometimes we turn to that abundance and we say, oh my gosh, a pest. If you see a swarm of locusts, even the BBC, even David Attenborough calls them pests, but they're not. They're abundance of life. But they're declining. And that's a surprise. I think, you could actually put a probability on the largest organisms are the first ones to decline. But we didn't think maybe the small ones, like the insects, would also be declining. And that could be even more serious. You could remove all the birds from a forest and still have a functioning forest. But you can't remove all the insects and still have a functioning forest. You see, insects are the glue, I call them. They're in charge of what I call the brown cycle. That's the turning over nutrients. When you go into a forest like Muir Woods, what do you see? You see giant trees. But what you don't see is that behind all that is the turning over of nutrients. The insects are like the vacuum cleaner, along with banana slugs, but they're the ones that are turning over that life into the components that can become new life. And if that's declining, that means we have a systematic problem with our process of life. And we're part of that, and we have to accept that. The ecosystems are not something different than what we are in. And that's the hardest thing for us to realize when we're inside our homes, when we are, when an environment comes in our house like an ant, we think it's terrible, but actually it's a rare occasion that we're actually reminded that we're part of the environment. And that glue, if it's declining, I think it's a more serious threat to our survival than the decline of birds. Now, we love anything that's warm-blooded, a mammal, a bird, but it's maybe more serious to think about the decline of insects than anything else.
I guess I asked the question because I was just, many birds eat insects. So I was just wondering if that was part of both of their situation.
Yes, well, I think they're related. Habitat destruction is the principal cause of decline of almost all life, even insects, and especially birds. And of course, if there are fewer and fewer insects, there will be fewer and fewer prey for the birds to eat. So they are related. There are so many obvious reasons, I think, for humans to perceive why we're losing birds, and that would be obvious of urbanization, habitat destruction. But I think we never thought that would actually also impact insect communities, which means the forest sometimes may be just the living dead. It's not an actual functioning forest because it's missing that component, the glue. We cannot think of a forest without also thinking of insects.
And in regards to the insects and their decline, is it more habitat destruction, or how big of a role do pesticides and insecticides play in?
It's an obvious question, and we don't know the answer. To get the answer, we should have been monitoring insects for the last 30 years. Our studies aren't very well, for once, insects are so overwhelmingly diverse, it's hard to imagine how many species there are, let alone how to monitor them. It's only really thanks to new kind of genomic techniques that we can actually think about in real time, trying to monitor the diversity of insects in a forest, for example. And those tools are just now coming online, and we didn't have those 30 years ago. We do have some crude measures, and it's those crude measures of abundance, weight of insects that are declining through time, or just some points around the world where we've watched insects decline at those localities. But we don't know any causality why this is happening.
Just some personal background. What drew you to studying ants, and what has changed in the last 30 years since you've been studying them?
Well, when I began, I didn't know I was going to study ants. In fact, I wanted to explore tropical forests. In fact, forest was what I wanted to study. I wanted to study plants. In fact, I was lucky to go and go to Panama when I was an undergraduate and work with some great botanists. And they were doing some amazing things. They started working for a conservation group called Conservation International. They were flying to new forests and exploring them and figuring out if the plants there were unique and if that area should be a new park, for example. And I thought that was so amazing, and I wanted to do whatever they were doing, and I started traveling around and collecting plants. But I also noticed everywhere there were ants, and I kept asking the botanist, how do I learn about these ants? And they said, nobody knows about these ants. There's no field guide. We don't know anybody that's an expert in them. So I started collecting them, and pretty soon I actually became more interested in the ants than I did the plants. They're not that different. It's just a P and an L, and I could switch quickly.
And since then, you have written a field guide and created AntWeb, so you are the Ant Man.
Yes, I've devoted my life actually to doing what these initial botanists taught me, how to travel and inventory a location and try to assess the importance of that locality in terms of its insect community, using ants kind of as the indicator. But to do that, I realized that we're going to have to learn a lot about ants. We need more people studying ants, so I created these resources online to actually have the tools so that anybody, anywhere could actually access this library of life that's kind of hidden in collections around the world. But if you're in Madagascar or in South America, you want equal access to that. So I created this online tool, and then I started creating field guides. We have the ants in North America. We have the ants of Madagascar that got published last year. And in 2016, it published the ants of Africa and Madagascar.
And you've ID'd over 1,000 ants, including the Dracula ant, which I bring up in part because on the Fisher Lab website, one of your stated goals is to increase what you call bioliteracy and to connect people back to the environment. So I think, do you mind telling our listeners a little bit about the Dracula ant? I think that's an easy one to get excited about.
Sure. And so when I went to Madagascar, for example, I wanted to demonstrate how we could use insects like ants to help document diversity and understand if the current park system is protecting the diversity of insects, for example. And I wanted to just know if that was true or not, or if we needed other parks. So I started traveling around Madagascar. Now, when I got there, there were about 200 species known for the island. Well, I quickly found out there were a lot more. We discovered with my team over 1,000 new species of ants just in the little island of Madagascar. And in the process, not just new species, but whole new lineages of ants, like the Dracula ant. Now, this Dracula ant is kind of different than the everyday ant that enters our home. That's a modern-day ant. In a sense, it has a social structure that is, in a sense, like our society. It's got a good system for delivering food around inside its colony. And that's done this way. So this is the modern ant. An ant goes out and forages. And, do you know why it brings back food to the nest? Most people think it's just being nice, but actually it has to bring food back to the nest, the colony, because that's where the stomach is. Now, to understand ants, you got to think this way. You got to think that ants are this superorganism. The individual ant is not the ant. The whole colony is the ant. It brings the food back to the nest. It feeds it to the larva. The larvae are the stomach. The adult ants can't eat solid food. It brings it back to the nest, feeds it to the larva, and then the larva regurgitates the food, and a few ants, the adult ants, suck up all that liquid they can drink, and they put it in their social stomach. And that social stomach balloons out, and it walks around that ant and goes up to another ant and says, "Hey, you hungry?" If it's hungry, it squirts out that liquid, and the other ant drinks it. And that's how it has a food delivery system throughout the whole nest. It's pretty efficient. Even the queen gets food delivered that way. Now, the Dracula ants don't have that system. Each ant has to go to the larva that's eating and actually scratch the larva, their sister, until it bleeds. And that blood then is the food for the whole colony. The ants have to drink the blood of their sisters. Each one, they don't have that social stomach that allows them to share it around. And that's why I call them Dracula ants. Now, in the literature, we don't call it drinking the blood or Dracula ants. We call that non-destructive cannibalism. It's quite unique in the Dracula ants.
Okay, so I've read that you say ants in particular provide better climate change data than other insects. Why is that? Why are ants like a better indicator?
Well, ants, and I would say other insects too, but in particular ants, because they're one of the dominant insects in a forest. If you go into especially a rainforest, the bulk of diversity are the social insects, especially ants. So you couldn't remove all the ants of a tropical rainforest and still have a functioning ecosystem. And therefore, ants, because they're so dominant and there's so many ecological interactions, meaning they've taken on all these roles in the environment. So they're like the lead players in every play that they can get involved with. Whether it's seed dispersal or vacuuming or predators, prey, everything. They just do everything. And that's so neat about ants. And I can explain why ants have been able to do that while other insects haven't. But because they're so dominant, they're also like an indicator group that should be monitored. And every environment is different and you would kind of gear it differently. For example, if you were in North America, there are also ants that are really important. That some of these ants, the mound-building wood ants, looking for the common name, they are stationary and they could be there for like 40 years. Most people don't realize a queen ant could live like 40 years. The workers may turn over quickly, like leaves on a tree every couple of years, but the queen could live like 40 years. And that's a dominant structure. And underground, it's as big as an elephant. It's an important part that we kind of ignore and only see the tip of the iceberg when we see that mound.
And to save a forest, you advocate for eating insects.
Yes. Now, my love is ants, and I've traveled everywhere looking for ants. And they're fascinating, as we've just discussed. There's so many interesting things about them. But the more I've traveled, the more I realize that the forest is disappearing. And I began to ask myself, why aren't I doing something about the forest? Or can I do anything about the forest? Soon there won't be any forest. And I kept thinking, I have to just work faster. I have to go to more forest faster, discover more species before there's no more forest. And then I said, well, wait a minute. I actually have to. Consciously, I have to start doing something to help save the forest. Of course, the work I'm doing helps us monitor and understand the forest, but it's not saving trees. It's not replanting trees. And when you get down to it, it's an interface between people and forest. And I didn't know if I could do anything, but then I just realized that insects have a role. In fact, in places like Madagascar, and it's common everywhere, that people have eaten insects. And that's an important part of knowledge about a resource that's disappearing. So in Madagascar, we began surveying what insects people eat now. And we're up to about 110 species across the island of Madagascar. And the idea was, could we actually use kind of modern technology to rear these insects or some of these insects at a kind of a large scale that would help provide food security? Because poverty is linked to food security, is linked to environmental degradation. And if we want forest, we're going to have to figure out how to help the people living outside the forest. I've been focused on just the forest, and now I wanted to figure out how I could focus on what's happening outside the forest. Now, historically, people ate insects. It just makes sense that it's a viable food option, but there's a lot more to it. One, it's sustainable. Now, we often farm, for meat, for protein, a mammal, a warm-blooded animal that takes a lot of energy to keep it warm, a lot of energy at times and water for it to cool its body. But an insect doesn't have to waste any of that. In other words, it has a higher conversion rate. You feed it a pound of food, it can convert more of that pound to protein than a cow, about 6 times more than a cow, than a pig, about 3 times more than a pig, and about 2 to 2.5 times more than a chicken. In fact, if we want to actually take our given amount of resources we have that we're feeding mammals and feed insects, we'd have about 6 times as much food for the world. Now, put that in the context of Madagascar, where there's often periods of widespread famine, and one of the reasons we're having such high deforestation now is because of immigration within the country of Madagascar. When there's a famine, people move north, they colonize the forest, they cut down the forest. And if we could actually provide them ways to sustain their societies using their traditions, it's a win-win. And even more so, if we don't, they're eating all the forest. They're eating the lemurs because that's the only protein they can eat. Or they're going to try to put more cows on degraded lands. They're going to actually try to cut down the forest to grow corn. There's no good option. With the populations that are going to double in the next 30 years, for example, in Madagascar, there's no other option that they'll have unless we go back to this tradition and combine that tradition with some new technology. And that's what we're trying to do in Madagascar. I think it's a solution that's not just for Madagascar, but we're trying to prove that we can address food security, we can address famine, and we can actually save the forest. Now, saving the forest isn't maybe so evident, but you see, when you, for example, farm crickets to eat, you get equal amount of crickets as you do fertilizer. You see, the crickets produce a manure that's actually fantastic. We're using that manure now in reforestation programs. In fact, it's very effective, more effective than chemical fertilizers, because somehow it activates the soil and helps that soil come back alive. And I think it's going to be a key for turning these landscapes from a degraded, kind of barren lunar landscape back to a green landscape. It's essential we find a way to turn these ecosystems back into something that's better than what they are now. By farming insects, we can do that and provide food security. And that's the win-win for Madagascar.
Well, here in Marin County, where you live, it's known for being sort of a foodie community. How many of your neighbors do you think will eat bugs?
That's a good question. People think, oh, yes, fine for Madagascar, but here we're quite fine. But actually, people eat the insects. When we're in Madagascar, why are they eating this? It's not because it's like their only choice. They're not doing this because they think, oh, this is good for the environment. They're eating it because it tastes good. And that's what's exciting. In fact, so 4 of the top chefs in Madagascar are developing new recipes. We're working on a cookbook right now of fantastic recipes that build on their tradition, but also offer new ways of presenting their traditions in kind of haute cuisine. And that can also be of interest here in like Mill Valley. And I think that's one way to introduce this concept. I mean, if you talk about, eating shrimp, people are like, oh, it's great. I love shrimp. If you say, how about a cricket? And they're like, what? But it's actually the same thing. They're related. Just call them land shrimp, and people will start eating them. And it's really up to our societies to realize we have to be more open to change. We have to be more willing to take greater risk of how we change, or else we're not going to have any options here too. I think we already get a sense. I think all these fires and the PG&E cutoffs are actually maybe waking us up that maybe this is not something that our children have to deal with. We have to all deal with it now. And we need to start thinking out of the box. And it's changing. Change is hard. But if it tastes good, it won't be so hard.
And I'm looking at something right now, some samples you brought in.
Yes. In fact, what I have here is what I have for breakfast every day. So I start off my day with some yogurt, and I add in 25 grams of cricket powder. This powder is actually from our farm in Madagascar. And I mix it up, and I add some granola, or you can eat it plain. In fact, what I want to do here is mix it up and have you taste it. So I always say to people, if you're allergic to shellfish, you probably should be tested in small quantities at first. And then if you have no reaction, no throat itch, then go for it. But some people say this tastes more like chocolate than anything else. So welcome to the new world.
All right. Thank you. I'm excited to try this.
Wow, you're a whole spoonful. There you go.
I was not afraid.
What do you think?
It tastes good. I mostly taste the yogurt. The texture is good.
And that's what it is. It's not the meal. You're not going to sit down and eat a bowl of protein. You're going to mix it with things. Now, I think this is a great way, and people actually love it. The kids love it. The school lunch programs we have in Madagascar, they eat it like this. But if you're just want to have a snack, I would suggest this. Now, this is a lime chili mix. We have mini mixes, and I want you to give this a try. It's kind of, you can have this with beer. You can just have it as a snack while you're studying.
Yeah, I think if you call it spicy land shrimp, people will buy it.
Well, very good. It's interesting. When we serve this at school lunches, we have about 10 schools in Madagascar where we're providing lunch programs. I don't think the kids ever question, like, they don't want, like, insects. Of course, we love insects because as kids, they all eat insects. But the adults are like, oh, I don't know if the kids will like this. And then they're like watching the kids, and then they start eating it too. So there is some hesitation by adults, even in a place like Madagascar where insects are eaten by 70% of the population. But people keep eating it, and they keep going back to it because it tastes good. And how you preserve it, how you present it, it's just like anything. So it's up to imaginations of how you can make a good meal.
I wasn't planning on asking you this, but I did have a thought. So I normally have a vegan diet, but I've been very receptive to eating bugs for the very reasons you shared a moment ago. So is there a word for somebody like me that only eats insects as the only sort of protein that's not a plant?
A word? Actually, no. But vegetarians have come to me and explained why they don't eat mammals. And there are many reasons why you don't want to eat an animal. But our farms, and I think all the edible insect farms, actually harvest at the end of life. So we harvest an insect after it's an adult, after it's laid eggs, after our goal is to harvest 2 days before they would die naturally. So it's all timed to harvest 2 days before they would die naturally. Compare that to a chicken, a cow. They're juveniles. They're at their prime when they're harvested right now. So in a sense, it's basically when they're about to die, because we need them to have lay eggs. We need them to be big. And that's when you harvest. So in terms of like killing a juvenile animal to eat it as a steak, this is far better.
I don't want to turn this interview into an advertisement, but they're also full of nutrients and iron and protein as well, aren't they?
Right. And so this is another reason why in like Mill Valley, people may be interested in this, is because it's a really, really healthy diet. Now, if you ate a steak, compare that, about 25 grams of protein, compare that to eating 25 grams of insect powder, you would absorb more micronutrients from eating the insect than you would the steak. And the availability of those nutrients is important. So important that it's one of the reasons why people, like in our program in Madagascar, we're actually providing insect protein for the meals for TB clinics, tuberculosis clinics. And we just started very slow. They were kind of interested, and they said, okay, we'll give to half our people in the clinic 3 days a week for lunch, cricket protein, and the other half won't get anything. Those half that got it started gaining more weight, and they started responding better to the treatments, because the medication for TB really only works if you're healthy. It became such an issue that everybody noticed it, the doctors there, but also the other patients. And the other patients demanded they also get the cricket protein. And then they all got together and demanded it every day of the week. And then they expanded it to all the TB clinics in Madagascar. So that's also important for us, especially our children, because you don't have to actually worry for the rest of the day if you have it in the morning, if your children are eating properly. They've got all their protein and their nutrients basically for the day in 25 grams. So that's the kind of the daily, 1 large spoonful a day is what you need. Now, also, there's a lot of new studies that are digging into why this is happening. And we actually, and I think they're onto something, that it improves our gut biome. Something about the insect chitin, the exoskeleton, the high protein, somehow is great for our biome inside our guts, and that allows us, by improving it, to absorb more nutrients. And we found the same for our famine relief work, that those children that are fed insect protein are less prone to diarrhea and therefore are gaining weight faster, I think because their gut biome has improved. And that's why people want this more and more in the famine area, also in the health clinics. And for school lunch programs, they like it just because it tastes good.
You mentioned something earlier. You touched on something earlier that I wanted to talk about. Your desire to save the forest. What can you do? And I feel like it's been reported, or I've seen this cliche that scientists are bad at speaking publicly and defending science to, say, the policymakers. And when they're confronted, say, on a TV show with, say, a lobbyist who knows the talking points, that they don't know how to respond just because they're perhaps focused on facts and research and don't know how to communicate at that level. Has that been kind of behind the scenes what you've seen among some of your, I don't want to say your peers, but just do you agree with that cliche, I guess?
I agree with that because problems are complex and scientists see that complexity. And sometimes that complexity can hinder how we communicate the solutions or the rebuttal to a false solution. And, you could say, why don't we all have solar energy? Why don't we all have, in Madagascar, why is our forest declining? You could just say it's poverty. We'll give them money. But it's not that simple. And we see all those complex issues behind the scenes, we see the research that in that situation presented that solution, while in that situation presented another solution. But at the same time, we're running out of time. It's hard for me to imagine if we continue, if there'll be any forest left in Madagascar. Last month in November, I was visiting a region of Madagascar that's had a very difficult time. It's really, really beautiful forest. Tourists know it as the Gallery of the Baobabs. And there was vast forest there, but half of it disappeared since 2015. To me, those are shocking numbers, even for a country like Madagascar where it has deforestation. But this is shocking. And what's happened is people from the south have moved up because they've had famine and lack of food. So they moved up. They colonized the forest because that was the only land they could cut down. And half the forest is gone. So what's the solution? It's, is it keeping the people, build a wall? Is the solution to give them food? Is the solution to actually have armed guards around the forest? It's so complex because the needs, if your children are hungry, you will do anything. And for that reason, we actually is a place where we want to start farming and we want to see if we can actually help them. And I don't know if we have the answer for every solution, every problem, but there I think we can provide something that provide these people that are living in a barren landscape where we want to turn that landscape back into forest, where we want to actually provide a system that they can actually stay put and live and have a secure future for their children.
Well, on that note, what gives you hope? Like when you see this, like what motivates you to find hope in our future?
Hope will only be realized if we start working together. And as a biologist, I've only done biology. And sometimes NGOs that work in like famine relief have only done famine relief. I think I have hope now because people now are willing to work together in much more holistic solutions that deal with the kind of the economic fabric that has to be there, the social enterprise, deal with the social fabric of society and the environment. In the past, it's always been one or the other. Either you're going to save the environment, or you're going to help the people, or you're going to deal with famine. But none of those are long-term solutions. By working together gives me hope that we can provide solutions. Of course, it's going to take longer. Of course, it's going to be harder. Of course, it's going to require us to do things differently. And I want to be part of that. And I think we are helping that we can provide a sustainable and economic solution that helps the environment and gives children a future. I've seen it happen. And I think if we expand this in Madagascar, we can actually expand this further into Africa. And it's a place that I think all can benefit from thinking of holistic solutions.
Great. Well, thank you for trying and doing everything that you do and for taking the time to speak with us today.
And I'm glad you had a chance to taste our crickets.
It was delicious. And again, this is not an advertisement, but I liked it.
Thank you, Andrew.
Thank you.
Borrowed Time is a collaborative effort by librarians to combat climate change by discussing sustainability issues and all things related to the human influence on our ecosystem. For more episodes, visit borrowed-time.org.